Hello and welcome to this video. In recent years, drones have become an essential tool for creating breathtaking imagery. Naturally, I got myself a popular, ready-to-fly drone as well. However, one thing I never got into was FPV drone flying. That's why I was thrilled when I was given the opportunity to design and print a solid metal part at Additive 3D. I jumped right at the chance and started building my own FPV drone frame from scratch, taking advantage of the benefits of additive manufacturing. In this video, I would like to take you on an exciting journey as we explore the process of building a drone frame using 3D printing and explore the world of additive manufacturing together. Additionally, I hope to share my own passion for this field with you and inspire you to join me in exploring its possibilities. So here we are. Additive 3D is a provider of additive manufacturing machines and solutions based in Germany. The company's main focus lies on the so-called laser powder bed fusion process, which we will discuss in more detail later. For this project, we will be using the first machine ever built by Additive 3D, the Additive Zero. This machine has been a workhorse ever since the company was founded. In fact, if you are using an Additive machine yourself, there's a very good chance that some of its components were actually built on the very machine we are using today. As you can see, it is quite a large machine and its build volume can easily fit a 5-inch drone frame. Before we dive into the printing process, let me take a moment to discuss some key aspects of the frame we'll be building. It's important to note that this frame is not optimized for the best possible performance. It's not optimized for aerodynamics, weight or fast printing. Topology optimization or generative design approaches have not been used either. In essence, this project is a fun experiment that has resulted in a functional, unique drone while practicing design for additive manufacturing. That said, there are a few design elements that I'd like to draw your attention to. Weighing in at around 80 grams, the complete frame is within the range of popular FPV freestyle drone frames, but not quite as light as the racing drones out there. There are various mounting points all around the frame to attach electronics and accessories. The motor cables can be safely routed through the hollow arms, providing protection from the propellers and any potential hazards in the event of a crash. While the rest of the drone was modeled in standard CAD software, I developed a custom workflow to generate variable density Voronoi lattice structures for the side walls using a variety of free tools. Similar to other 3D printing methods, support structures are required when printing overhangs with laser powder bed fusion. Although I attempted to minimize the amount of overhangs during the frame design, some compromises were necessary to achieve my vision. Since time was limited for this project, I decided to err on the side of caution and included more support structures than may have been strictly necessary, which you will see later in this video. Now that we've covered some of the design aspects of the drone frame, let's move on to the exciting part, the printing process. Let me give you a brief overview of how laser powder bed fusion works while you can enjoy the beauty of the process. This 3D printing method uses a high-powered laser beam to melt and fuse together layers of metal powder, creating a solid object layer by layer. As each layer is completed, a new layer of powder is applied and the process is repeated until the object is built. Unlike other 3D printing methods such as FDM, you can only see each layer as it's being processed. This means you have to wait patiently until the entire process is finished to see the final part. I'm going to leave you for a few moments while the printing continues and I'll be back with you shortly to inspect the final result. That went well. Let's take a closer look. As you can see, the finished part is still attached to the substrate plate. In case you were wondering, the other part next to it is a completely different part unrelated to the drone. We use a wire EDM machine to remove the drone from the substrate plate. This greatly reduces thermal and mechanical stress compared to other mechanical solutions. As you can see, the water in the tank becomes cloudy over time until the drone is no longer visible. Now that the frame is separated from the substrate plate, it still needs some post-processing. There are still a lot of support structures attached to the drone. During the process of manually removing them, I began to regret having placed so many, although it was probably the right decision overall. So this is it. Here is our finished aluminum alloyed drone frame. I think it turned out really nice, but naturally along the way I also found a lot of things I would like to improve upon if I were to start over again. Unfortunately, I don't yet have the motors or electronics needed to fully equip and fly the drone. But don't worry, I promise there will be a part 2 to this video where we'll see the drone take off. To all, I have the drone frame sitting right here on my desk and I can't resist the urge to let it soar through the skies much longer anyways. I hope you enjoyed following along with this process and learned something new about 3D printing metal parts. If you have any questions or feedback about additive manufacturing, laser powder bed fusion or the drone's design, leave them in the comments and I'll be happy to discuss them with you. Finally, I would like to thank Ecology 3D for making this project possible. Thanks for watching and I hope to see you again.